Let's study some important terms in nuclear physics. Mass defect. The actual mass of atomic nucleus is always less than the mass of protons and neutrons present in the nucleus. When a nucleus is formed, energy is released. This energy is removed in the form of reduction in total mass. This missing mass is known as mass defect, and it accounts for the energy released. So we can say that if there is a nucleus X, atomic number Z, mass number A, then delta M means mass defect will be equal to mass of all protons Z times MP plus mass of all neutrons A minus Z times mass of neutron minus mass of nucleus. Now, packing fraction. Mass defect per nucleon is known as packing fraction. So, packing fraction PF will be equal to mass defect as calculated above, delta M divided by number of nucleon, that is A. Now let's see what is binding energy. The minimum energy required to separate nucleons into its constituent protons and neutrons is called binding energy. It is given by EB equal to delta M C square. So as we know, delta M is the difference in mass of protons and neutrons sum reduced by mass of nucleus. So we can say, suppose as we have already discussed, suppose we consider a nucleus Z A. So this is number of protons. So Z times mass of proton plus A minus Z neutrons will be there. So A minus Z times mass of neutron minus, let's say, mass of nucleus is M capital N. So this difference will represent mass defect, and when by Einstein mass energy equivalence relation we apply, so we get binding energy. So delta M times C square means this value ZMP plus A minus Z Mn minus M nucleus whole times C square. So this will give binding energy. Now binding energy per nucleon we can find by dividing mass number to this energy. So here mass number will be A. So we just divide by A to this value to get binding energy per nucleon. Let's understand it by an example. So suppose we are given a nucleus. Suppose we consider alpha particle. So alpha particle is 2He4. So here protons are 2, neutrons are also 2. And suppose mass of helium nucleus is also given. Mass of 2He4 is given, and that is 4.00228 AMU. And mass of proton is given as 1.07825 AMU, and mass of neutron is 1.00866 AMU. Now suppose we have to find out first mass defect, then binding energy per nucleon. So let's calculate the mass of protons and neutrons. So twice of mass of protons plus twice of mass of neutron will be 2 times 1.00785 plus twice of 1.008665. So here the total sum will amount to 4.03298 AMU, and mass of nucleus is given 4.0028 AMU. So mass defect delta M will be the difference of the two, 4.03298 minus 4.0028 AMU. So this will be equal to 0.03018 AMU. Now we can find binding energy. So binding energy will be mass defect in AMU times 931 million electron volt. So 0.03018 times 931 MeV. So that will come out to be 28.097 MeV. So this is how we calculate binding energy per nucleon. Here we have calculated total binding energy, and then we have to divide it by 4 to get binding energy per nucleon. Thank you for watching.